my goal today is to help you really learn a bit about Spark NLP really as an open source project that's actually been used right now in LLM days, even more than it was used kind of in the old NLP and deep learning days. So we'll talk a bit what the project is, and then really the three main use cases we are seeing kind of map to the three last major versions of the library. So Spark NLP is an open source library. It's Apache 2.0 licensed. It's widely popular. It's it's been around since late 2017. As you see, more than 160 million downloads, and that's really just PyPy. That excludes Conda, Spark packages, Scala, and kind of other ways to get it. There's been an active team working on it for over 8 years. And really what it provides this kind of very comprehensive library. Really start with analyzing text, although today people use it for other modalities as well, as we'll see. Starting with really simple things like I have text, I need to split it into paragraphs, split it into sentences, do tokenization, do spell checking, extract entities, extract relationships, all the way to now really embedding LLM-based tasks like question answering, translation, summarization, paraphrasing, different types of classification, and doing it all at scale within one pipeline. Spark NLP is heavily deployed in production across just about every environment. So in this slide are some of the environment that we officially support and we officially test against. And you can assume that on everything you see here, there are quite a few, in the thousands at least, teams, systems that are deploying production, are deployed at scale and use this. So we've gone through the early years where those things did not work right, or you had to make each of the environments actually work well, but that's behind us now. And you also have a community and a lot of documentation behind it. And we've also made the library much easier to use over the years. So if you want to use it, really, you do from Johnson Labs import NLP, and then you have quite a few one-liners where you can just do NLP load NER if you just want to do kind of basic name entity recognition in English. For example, you give it a text and it gives you the results. And this works on strings. It also works on complete data frames, and it also works on Spark data frames if you happen to have a petabyte of text that you need to work this on. So that's really one of the nice things about this library, is the ability to scale without code changes. So you can start with one-liners, or you can build complete pipelines if you need to. And people use this heavily when you need to analyze different text. But really, the real question is, okay, that's all well and good, but like, do we really need it in the LLM days? Really, what are the use cases and what we would use it for? And that's what I want to talk about today. And there are three main use cases. The first one is efficient calculation of embeddings when you're building a RAG database. So the classic RAG LLM use case is a case where you have a set of documents that you want to build a knowledge store from. So let's say you're looking at all legal precedents for say corporate law, right, from this state, and you want to put in a knowledge base to make it easily searchable. All the 2 million resumes that you got over the past year, right, if you're recruiting for candidates. And what you do, you take the documents, you may want to split them, chunk them, clean them, but then at the end of the day, what you do, you take the documents and each one of them you convert into a vector, an embedding vector, and that's what you put into your vector database. And vector databases really, they have only one trick, which is when you have a query, right? So let's say you put in, here's the job description, you convert this query also to the same embedding models, and then what the vector database does, it gives you the documents whose vectors are basically mathematically closest to the vectors and to the query vector, and that should hopefully mean also semantically close. So the challenge that specifically we're working on here is, what do you do if you have many documents that you need to actually put into a vector database? Because that's often been a scaling challenge, and you still see vector databases that never demo in anything over, say, 100,000 documents. Because first things start breaking at that point. The other thing, it takes a very long time to actually populate the database. The standard way people do this, if you just use either an embeddings API, you use Hugging Face and use one of the embeddings there. So Spark NLP is a free open source alternative to do this, to basically to calculate embeddings efficiently. What you can see on the left is an example of a pipeline. And within Spark NLP, what you do is you take different models or LLMs or step and you put them into a sequential pipeline, like you can see here. The pipeline class is the Spark NL pipeline class. And this is what gives the library its nice ability to scale on any Spark cluster. So it's not its own specialized thing. It's actually we use and we enjoy all the optimization that Apache Spark already provides. And here you have one example. We get the documents, we convert them into text, we split them into sentences, we tokenize them, we normalize them, and then we calculate. In this case, we calculate word embeddings, right, for those normalized tokens. So this is one example of a fairly simple pipeline. When you have a pipeline, you can do two things with it. You can do a fit if you want to train or fine tune your model. So that's really all you need to do. Or you can just apply it, right, on text that you have. Within the Spark NLP code base, it's first of all, one thing to say, it is its own code base. So meaning we do not use other open source libraries under the hood or Hugging Face implementations or other embeddings implementations or other ones. This was built from scratch to be optimized for speed. And also there are three separate builds. There's the Intel optimized build, and Intel actually contributed some open source code to make the most of its latest hardware. There's an NVIDIA optimized build for CUDA, and there's also a NEC optimized build to actually use the latest Apple chips, Apple hardware. What it means that because this is code specifically written, specifically optimized for speed, specifically optimized for those types of hardwares, even if you don't scale, even if in this example you only look at the single machines, what you're going to see is for this use case of calculating embeddings, if you use and you have the exact specs, but in general, you should expect to see somewhere between 3 and 4x speed up compared to really just using Hugging Face with the exact same embeddings. I think with Spark NLP right now, there's I think 130 somewhat thousand different models, or several tens of thousands of embeddings that are there as part of that. If you're using a quantized model, then the gap is even bigger because quantized models they're just smaller, which means the fit. Spark can do a better job of using multiple cores and processors to apply them. But one point is really, even if you're not interested in scale at all, you're going to see here a material speed up. If you are interested in scale, this is where really this becomes the library, the kind of the go-to library for organizations that need to look at that kind of scale. And here you can see what happens when you go from a single node, 2 workers, 4 workers, 8 workers, 16 workers. With Spark NLP, the cool thing you do is with no code changes. You just give it a bigger Spark cluster to work with. And you can see that, especially as the number of embeddings that you need to calculate grows, you get really near linear speed up in this case. And of course, there's a lot of engineering work to make sure that this happens. So for example, you can see the example here at the bottom of a slide, but when we wanted within Johnson Labs to build a knowledge base of all of PubMed, so all of the biomedical and medical articles, which is about 40 million papers, and goes by about 1 million every couple of months. It was basically simply impossible to do with a kind of your classic open source libraries. It would take 2 weeks to calculate all of these embeddings. And here you can see we got it down to minutes. And not only did we get it down to minutes, we got it down to minutes without any code changes and really just scaling on commodity hardware, right? So this is not having a bigger, more expensive GPU. This was actually sticking with small machines and just having a few of them run in parallel, only for the duration really of those few minutes. So that's one use case, being able to calculate embeddings for RAG. So really, whenever you're crossing, 100,000, 200,000 documents for your knowledge base, definitely that should be something Spark NLP should be also a free open source tool to consider. The second use case where the library is relevant is really when you're trying to do batch inference at scale and need an LLM. So let's say you have a data set like the one on the slide here. So you have text, but you don't have 10 rows. Let's say that you have 10 million rows, right, or 1 billion rows. So for example, you have a large body of document, large body of text, and you say, okay, I need to translate all of this to French. I need to summarize all of these emails or all of these customer support tickets, right? I need to answer a question, right? Oh, should this be escalated? Yes or no, right? Who is the right person? Who is the right customer support service at our team, at our company who should reply to this question? I need to do information extraction, right? So extract structured data. But the point is, there's an LLM a question or prompt or a set of prompts that you need to apply. And what you don't want to do is use an LLM API, because then you're going to have to pay per token. You're going to have API rate limits, right? And you're definitely going to hit rate limits if you're talking in the millions of entries that really need to process. So really, your question is, okay, look, I just want to do, can I do batch processing that does not call a third-party SaaS API that runs efficiently? And within Spark NLP, this is a very, very simple thing to do, because calling an LLM is really just another step in the pipeline. So you can really just have a pipeline that says, okay, here I have a PDF, okay, extract these images or documents for the PDF, okay, split them into sentences, okay. Now I want an LLM thing, okay, summarize this or paraphrase this, right? Because this is, for example, part of a legal document, academic paper, loan application, whatever may be the case, okay. So that will be an LLM step. Then you can have another LLM step, okay, now translate this to Russian, please. Okay, and then you can go back to other kind of more normal NLP steps, like do spell checking, right? Do grammar checking, extract named entities, right? Run a classifier, and you can do it. The nice thing is you can do it all within the same pipeline in memory. And pipelines, you can see each one of them just scales natively as on any cluster, on any commodity cluster. So this is also a very popular use case if you need to do really batch inference, but at large scale. Often people find that Spark NLP can be basically just the most time efficient and cost efficient way to do this. So cost is the major driver when you're doing LLM inference, as I'm sure everyone knows, whether you're doing it yourself on your own machines or you're paying per token, right, to some API. So being able to do this in an open source way on either small language models or medium-sized language models that you still run on your own, so it makes small projects cheaper, but more importantly, it makes larger projects they just economically viable, right? Because you can reduce the cost really to near zero. And so that's one thing. But the other thing to consider is that you should also expect better performance if you have very small data sets. And here's the benchmark I want to show here. So here's what we did here, and by the way, all the notebooks are public. I'm happy to share a link to them in the questions. We took a new summarization database of 59 kilobytes. Okay, so definitely not a large scale thing. To see if we can make this thing run faster, because a lot of the optimization work that was done was to make sure that we don't suffer from things like Spark overhead, JVM overhead, just parallelization overhead, and making sure that this still is an efficient choice, even if you have like a very small data set, right? Something in the kilobytes. And as you can see here, and this is also the notebooks are public, you're welcome to reproduce this. Of course, it's open source, people have reproduced it on a single, fairly small Databricks server. And the goal was really just, summarize, run a summarization pipeline, text summarization pipeline in English on 59 kilobytes. And you can see that here comparing to running Hugging Face on Spark, this ran really more than 8 times faster. So there's optimizations at the kind of at the small scale, right, to be able to run, because really this code is completely implemented from scratch. It's actually written in Scala under the hood, as well as the ability to scale. So cost-wise, what we see very often is that sometimes, because this is batch processing, sometimes people said, okay, this runs 8 times faster, cool. So, I can have my, 1 billion, summarization tasks, translation tasks run so much faster. But sometimes people say something different. They can say, okay, if it's 8 times faster, so what I can do is I cannot run it on GPU at all. I can run it on a CPU, and we have Intel optimized builds for the latest chips, which is going to be far cheaper. So it's not going to be 8 times faster. Maybe it's going to be the same speed or 2x faster, right, on a CPU. but the cost is going to be maybe 10 times cheaper, right? Because CPUs are so much cheaper than GPUs nowadays. And so, the example you saw below, we actually ran this just on a CPU. So you can see you can get, one summary every about, 3.3 seconds on a machine that only costs you, less than $450 a month. So that's another thing that's usually of critical importance, especially if you need to do these kind of things at scale, where cost really is very often is the first engineering concern of whether we do this project at all. The third and final use case that I want to cover is on multimodal information extraction, and this is something that was added in the V6, the latest major release of Spark NLP. Right now we're already at 6.2, so been I think 5 or 6 releases since then. But basically the asks that we got from the community was to say, okay, look, text is great, but can you please do something to enable same thing, this open source batch inference at scale, but for other modalities, because there are many more open source models that are multimodal and support that. So we have added those capabilities. What it means that now you can also use Spark NLP and the same pipeline concept to do things like, for example, image classification, image captioning. Okay, so let's say if now you don't have 1 million emails to classify, you have 1 million images, or even 1 million videos, and you need to transcribe them, you need to add captions, you need to classify them by whichever classifier you've built. So now you also have annotators, and you have really the whole optimized collection of open source models for different platforms that enable you to do that. So that's the another modality that's supported is speech. So for example, if you need to do automated speech recognition, that's basically supported. So when you start the pipeline, just as you can you can start with text and say, here load these documents. You can say here streams of audio and the streaming mode and the batch mode. But for example, if you have a product that says, okay, I want to take all of the recorded conversations that our customer support team had in the past year, 5.5 million of them in 23 different human languages, and I want to automatically transcribe all of them. I want to summarize them. I want to categorize them. I want to extract the main entities that we talked about, which products, which problems. Basically, you can just write one pipeline that does all of that and run it also without paying anyone for inference or per token fees, without exposing anything outside your infrastructure, right, from privacy compliance perspective, and run this on very cheaply on commodity hardware. So you can see there are quite a few models that are available to you kind of within the ecosystem. There are more high accuracy English only models. There are multilingual models that are models designed specifically for environments where you have a lot of background noise. There are models specifically designed for accents and specific accents. And you can of course choose and mix and match between them within the pipeline to get the best accuracy for your specific use case. Also, another kind of new modality is text that just get generated as part of the pipeline. So sometimes, yes, you can say, I have images, I have videos, I have PDFs, I have emails, I have free text. Okay. Sometimes you can say, no, I just want to generate the text as part of the pipeline itself. So that's now supported as well. You can actually, by generating the text, of course, by giving it prompt and deciding which small language model or large language model would do that work. So that's supported as well. We already talked about calculating the embeddings, and there are also now annotators to do things like re-ranking specifically for RAG applications. So you can really do that end-to-end work, including deciding what's the most relevant out of the document you just surveyed, if you're trying to kind of do those retrieval and search problems in batch as well. The other thing that's now available in the library is an annotator called Reader Assembler, and what it does, it simplifies things greatly for you by enabling you to come and says, look, I'm going to now feed you documents from all of these different file formats. Okay, I'm going to give you, Excel spreadsheets and HTML documents and some emails and some PDFs and some images and some plain text and some background. And I'm just going to throw whatever it is that I have, because I'm just looking at all attachments. I'm looking at things I got off I just downloaded it from the internet. It can be a whole mixed bag of things. And what you want to tell it is, look, just do the multimodal thing. So, if I give you text, okay, assume it's text. If I give you a PDF, here's what I want you to do. I want you to extract tables, right? So there are models specifically for extracting structured tables out of, say, scanned documents or PDFs. If you see images, extract the images as specific kind of binary images, because later I want to do captioning, I want to do a chart to text, for example, right? Do chart understanding. But as you can see in the code on the right, reader assembler, set readers. You say, okay, I want a doc, table, and image, which means if it's a document, I want to extract the text. If it has tables, I want you to identify the tables and extract the tables as structured data tables. And if you see images, I want you to extract the images. I'm going to give you here specifically HTMLs, right? So HTML, of course, can contain images, contain tables, contain text, of course, contains images that are tables. You want to extract, so all of that is there, and you just tell it where it is. So really, you just have this one path that enables you to say, okay, I'm going to support all of these file formats. I want you to apply all of these multimodal extractions, and then once you get into a pipeline, also you can do whatever you need with it, right? So you can say, okay, extract the text, cool. Now I want you to extract name entities, to do classification, do spell checking, do translation, do question answering, right? And you have the ability, kind of once you get it into your pipeline, you can do whatever you want with it later. So that really it's a full data processing, a batch data processing infrastructure. So with that capability, we do get a lot of questions on comparison to unstructured I/O, because unstructured I/O is basically this ETL platform that says, yes, give me files of all different types, and what I'll do for you is I'll understand all of these file types, I'll extract information for them, and there's some basic processing that it does, but mostly what it does, it does chunking, it calculates embeddings, and it puts into RAG databases. Now you can do that with Spark NLP as well, and we see more and more teams that choose to do that. And I do say it does look like there are different use cases where each one applies, and you have this table that summarizes them. But I would say if you want to focus really, there are three use cases where Spark NLP seems to be a better fit. One is where you really need the scale, okay, because the unstructured I/O is Python based, which means that the speed per document that you're going to get is not what we get with Spark NLP, and the ability to scale is usually it's more SaaS based. So really, I mean, they want you to be a paid customer to do that, to get enterprise level scaling. The second reason why you may want to consider Spark NLP is really if you're going beyond just extract the text from the HTML or email and do chunking and calculate embeddings. If you have a whole step of processing pipelines, I say, calculate name entities, find relationships, and normalize it to ontology, for example, going back to the previous talk, right? Do some translation, do grammar checking or grammar correction, some paraphrasing, right? And then that's what I want to send, for example, into my RAG database, write some enriched, normalized format. Then Spark may be just an easier way to do that, because you may not have all of these annotators and models available within the same pipeline. And the third and most important thing, of course, is that Spark is completely free and open source on Apache 2.0 license. So, there's no freemium model, right? There's no as a service. There's really, we have a team, but the only goal is to serve the open source community. And so you get the benefit of that, and also the benefit that, if you start a project, quite a few others who have already done, what you've tried to do, and have hit all of the usual aspects. So, we've gone through the years where we had to, provide better error messages, look at the logs, and look at, different Spark configurations with different cloud providers. And that's it's a fairly mature platform where it is as well. But of course, both of these choices have have the right use cases, and you just consider it another tool in your toolbox when the time is right.